In this figure, we're going to look at the adaptiveness of biological catalysts known as enzymes. And what we have in this graph on the left here is a change in Gibbs free energy between reactants and products. And in this case, we have a negative delta G because our products have less available energy than our reactants. In other words, energy is given off. That means that this is a spontaneous reaction as we've seen previously. Now, and it could go the other way. It doesn't really matter. Enzymes work for both spontaneous and non-spontaneous reactions. Now, what we want to look at more closely, though, is this hump, right? This energy of activation, EA, and that hump is often quite large, and that's an energetic hump, if you will. In other words, we have to add energy to get our reactants to combine to form products. In an uncatalyzed reaction, shown by the dashed line here, we have quite a big energy hump required for those reactants to come together and form products. That's despite the fact that this is a spontaneous reaction. And if that energy hump is quite large, as it's shown to be here, right, much greater than the initial energy of the reactants down here, um, we might require quite high temperatures to sort of exceed that energy of activation and actually get any products, despite the fact that it's spontaneous. Now, what an enzyme does is an enzyme comes in, shown over here, this blob down at the bottom here is the enzyme, and we have a single molecule that's being broken into two, or vice versa. The triangle and the square could be coming together. Enzymes do both. They sort of put things together and break things apart. But in either scenario, right, the components are bound to by the enzyme, and the enzyme lowers the activation energy for that reaction to occur. And so we're dropping from that dashed line down to this much lower solid line, reducing the energy of activation required, making that reaction proceed much more quickly at a reasonable temperature. Right? And so enzymes are really ubiquitous in biological systems because energy of activations are often too high for reactions to proceed effectively, even when they're spontaneous.